In this session, we are going to dive deep into performance monitoring. We will look at it both from the standpoint of how performance monitoring works in Microsoft Azure, and also look at how it is implemented in Nerdio for Azure with desktop visual synthetic monitoring. Enjoy the session.
All right, today we're going to talk about performance monitoring, and we're going to look at performance monitoring both from an Azure perspective as well as through the NAP that does visual synthetic monitoring of desktop workloads. So let's start with Azure performance monitoring. And recently they've actually, enhanced the monitoring to include some really interesting metrics that are going to be very useful in troubleshooting performance, even looking at things in the past. So let me kind of walk you through what's available. So if we go into the VM view, the virtual machine view, and you open up any virtual machine, you can click on metrics under monitoring, and you will see a screen like this. And this screen basically allows you to select multiple different metrics and kind of graph them and select the time frame, etc. So let's go through a couple of examples. So we're currently looking at RDSH01 in a demo account. So there's not a lot of usage on it, but we'll use it as an example. The next thing is we select a metric namespace, which in this case is a virtual machine. And then we look at metrics. Now, important thing to note here is there are going to be some metrics that are going to have nothing in parentheses next to them, and some metrics will have deprecated and preview. So the deprecated metrics are obviously ones that are going away. The preview metrics are the ones that are coming in. So there's going to be some interesting preview metrics that we're going to look at. But first, let's start with the simplest possible metric, and that is CPU, percentage CPU, right? So we're all familiar with percentage CPU. We can put that on the sheet. We can select average, which is going to be the aggregation algorithm. And what this is telling you is that for every sample data point that's on here, it basically is looking at the CPU utilization and averaging it out, I guess, over a certain period. And the time frame is listed here. And you can select different time frame and different granularity. So let's see if we change it to 1 minute, what that's going to look like. So we have more frequent data points. But thing I want to point out is this aggregation. Average is what we're all used to look at. However, average on a retroactive basis, if you're looking back in time and you're trying to pinpoint certain constraints, really what you care about is the peak. Average, if you have a peak that's maxing out the CPU for a very short amount of time, if it gets averaged out with a few data points around it that are not maxing out the CPU, it's going to skew the result and everything is going to look normal, even though there may be very high peaks that are persistent and are causing performance issues. So what's really interesting is that you have this max metric here that you can put in. And by setting the metric to max, you're actually looking at the peaks that the CPU is hitting. So right now we're looking at a 24-hour interval. Let's say we're going to look at the last 30 days. And with the last 30 days, gives you a limit because we have the data point set to 1 minute. That's too frequent. So let's see if we can do 5 minutes. We can. All right, good. So basically what max is showing me is where all the peaks are. So obviously this machine looks fine. There are occasional peaks. If we investigate, we'll probably find that this is either user logins in the morning or maybe updates running in the afternoon and things like that. So this is good to know that you have a metric for CPU usage, and you can also look at peaks by selecting max. You can also define your time frame and the time granularity. All of these are pretty powerful. You can also have different types of charts. So you can have like an area chart, for example, if you're plotting maybe two different metrics or from two different hosts. You can have RDSH01 and RDSH02, or you can have RDSH01 and DC01 overlaid on the same graph. So if you see a spike in one, you can readily see if there was a corresponding spike in the other and kind of find correlations visually like this. And various other, sort of visual representations that you can modify. What I want to point out is a couple of other metrics that we can add. So let's go ahead and add another metric for the same host, except this time, we looked at CPU, which is a common source of performance issues. The other common source of performance issues is disk I/O. And the thing that summarizes disk I/O pretty well is known as queue depth. Okay, and queue depth is now a metric that's available in here. There is a disk, the OS disk queue depth, and then there's also data disk queue depth. Because RDSH01 doesn't have data disks, it only has an OS disk, which is the C drive. Let's select this metric. And again, we are going to look at max. And let's get rid of the CPU so we can see this as a more representation that makes sense. So like you're looking at things and you can see what the maximum queue depth on that particular VM is. And this VM obviously looks very healthy over the last 24 hours. Queue depth is pretty low and it's pretty shallow. There was a peak once to 1.2, but even that is really not a big deal. If you had a machine that was struggling with I/O on the disk side, what you would see is that the queue depth would build up. Queue depth is basically a measure of how many operations are pending to be processed by the disk subsystem. And as the disk subsystem becomes a bottleneck, that queue starts building up. So the operating system is basically buffering all of those requests and storing them in a queue. And then as the disk becomes available, they get processed. So the times when the disk is really busy, it is going to start building up, and you'll see consistent numbers, at least in the single digits, maybe 2, 3, 4, 5, and certainly if you get into the teens or hundreds, then you have pretty terrible disk performance because the queue is being built up that high. So this is a really valuable metric to look at if you suspect storage as the issue. So let's look at it on a 30-day basis. It's lots of data. I guess it's got to pull it all and process it, but here we go. All right, so we have this disk queue, which you can see, again, we're looking at the max of it, not the average. Let's see what the difference is going to be if we do average. Well, actually, we'll switch in a second. But what you can see is that there were some times when the disk queue depth kind of jumped up, like this one, for example, is pretty high. If this is just a single data point, it may be nothing, but if you look at the exact time frame of this data point and there was corresponding user performance complaints, you can correlate that pretty well. So again, this looks overall fairly healthy. There have been some spikes. However, if you were looking at the average, let's see what the average would look like on the same metric. So I expect the metrics are right now, if our maximum is about 10, and we have a handful that are kind of reaching 5 or 4, I would expect that the average will smooth a lot of these out and they're going to be lower. Yeah, so you see this big one is much less, and then overall things look a lot better, even though there are peaks that at the time when they're happening, performance is affected. So again, important metrics to look at. One other thing to point out is there's now alerting that you can do in Azure. So if you click on new alert rule, you can define the resource, you can define the condition, and you can define the action group and the action that gets executed. What this is useful for is you can set certain alarms for performance metrics exceeding thresholds that you predefine, maybe the queue depth exceeding 5, or CPU utilization exceeding 95, or whatever the metrics that are relevant, and you can have a proactive alert go to a group of users who can then go in and try to remediate the issue, or at least be aware that it's happening, how frequently it's happening, and then adjust infrastructure. The important thing to keep in mind is there is an associated cost with configuring proactive alerts. Looks like it's probably about 10 cents per month per alert. So if you have, 100 alerts, you're going to pay about $100. I'm sorry, $10. So there's a cost associated with alerts. There is no cost associated with the type of monitoring that I was showing you on the previous screen. So this is Azure monitoring using various metrics and Azure alerting based on those same metrics that have an associated cost. All right, the next thing I want to talk about is desktop visual synthetic monitoring that NAP does. So to introduce the concept, let me kind of define what we mean by visual synthetic monitoring. Visual synthetic monitoring is a process that basically simulates a user action or user activity and then measures the time to perform various predefined tests or actions that that user may be taking. So instead of looking at the system backend and measuring things like CPU, RAM usage, disk queue, etc., and trying to extrapolate how does that impact the user experience, visual synthetic monitoring goes at it from the user perspective and actually looks at the screen and measures the amount of time a particular action takes. So this is built into the NAP, and it's implemented in the following way. So let's start from the top. So it's under the Optimize menu under Performance Monitoring. It's turned off by default. When you turn it on, what happens is there's a new VM that gets provisioned, and this VM is called a probe VM. It's a small virtual machine that sits in the environment, and as you'll see in a minute, it basically executes these tests on a regular basis, and then reports back to NAP what the results are. So here's the VM that gets created. It's called Perf Probe 01 for Performance Probe 01. It is a very small single core 2 gig VM. It doesn't really have access to anything on the network. It sits on the LAN, and all it does, it runs scheduled tasks that execute various actions as if it was a user logging in. Okay, so how does that work? So this is the VM itself. It's set up with a very predefined template, very predefined resolution, and it literally looks at the screen to see what happens. So when the VM boots up, or every hour since its boot up, it runs a script, and the script basically looks in a folder called targets, and the folder called targets has a listing of RDP files for the various desktop sources. So if you look here, you'll see we have an RDSH01, which is a possible desktop. We also have a collection, and then we don't have any users that have VDI desktops. For every VDI desktop and for every RDS session host, there would be a file, an RDP file in this folder. So just for the sake of time, let's narrow it down to just one file. These get automatically created and removed as desktops get assigned and unassigned from users. So what happens is it runs a script that looks like this. So I'm just going to actually let this run so you can see what happens. So it basically runs this operation, which logs in to each and every desktop VM, whether it's a session host or a individual VDI machine, and then it goes through a set of tasks. Now, I'm not touching my keyboard and mouse. I'm not really doing anything. This is the pre-configured set of tests. It starts out with an Outlook test. So it launches Outlook. If Outlook prompts for credentials or for activation, it knows how to react to it, and it basically, activates Outlook. Then it goes through and it sends a new email to itself. You can see on the bottom right, it's currently in online mode, so it's not cached, it's online mode. In a second, it's going to click the new mail button, and it is going to send itself an email. Okay, so right now it's going to, from the time it clicks the new email button, it's going to, okay, so first it tries to empty the inbox, make sure it starts with an empty inbox. Then it's going to send an email. And there's certain predefined delays to kind of allow things to run their course. Okay, there we go. It's going to empty out the folder. Okay. And there we go. Now it's going to send a new email. It will send the mail to itself. It will give it a subject. Okay, it's going to send the mail. And now it's going to wait until that email shows up in the inbox. There it is. So now it basically measured how long it took from the time it clicked new email to the time the email showed up. It deleted that email, and now it measured that particular action for sending an email. So the next thing it's going to look at is going to be launching a Word document with a predefined content. It's going to look on the screen and identify certain elements. Once it sees them, it says, okay, that document must be on the screen. So now it's going to do the same thing for probably Excel. Yep, it's going to launch a predefined spreadsheet. Look for the screen elements that it's expecting, identify them, and move on to the next test. If it tested PDF, it tested PowerPoint, it tested browsing the internet with IE and Chrome, and then at the end it showed the results on the screen for a few seconds before that screen disappeared. And it's going to go through this test every hour. So an hour from now, 12:25 p.m., it's going to do the same thing. The results get recorded in a database, in a SQL database or MySQL database that sits on the probe VM itself. And then that information gets updated on an hourly basis by the NAP. So if we go back into Optimize and we go to Performance Monitoring, okay, what you'll see is that there is a little refresh button and it tells you the last time it pulled in the data. So I'm going to click this button to refresh. It's going to pull in the latest data. And then here is where it summarizes the results. So the results are for this RDSH01, which has the following users on it currently. And these are the various tests that we were looking at. There was a test for logging into the desktop from the time you type in the password to the time it comes up, the icons come up on the screen. There is a visiting website through IE, through Chrome, sending an email, opening a Word document, opening a spreadsheet, opening a PowerPoint, and opening a PDF file. And then there are multiple data points. This is the last data point. So it took 11 seconds to log in, 3 seconds to browse with IE, 5 seconds with Chrome, 5 seconds to send email, 2 seconds, 2 seconds, 2 seconds, and 1 second to open a PDF. So you get the idea. Then there is the results for the day. This is the average of all the hourlies for the last 24 hours. And then there is the results for the past week, which is the average of all the dailies over the past week. If you click on details, it will give you a more detailed breakdown with graphs on what the results were. So you can see, we ran a test in the 11 a.m. time frame. You can see it's only, every hour there's one data point. So we ran this at 11. You can see how long it took. You can see there is a green threshold line and a yellow threshold line. I'll explain those in a minute. And all of these tests that we saw the system perform are listed here. So you can see that performance has been pretty stable for all of these. Again, the system is not under load, so that would be expected. And then you can go through and actually look at it on a longer interval basis. So you can see, for the past month, whatever the reason was, we had some really high login times that were happening between January 22nd and February 6th, and we can go through the system and figure out what changes were made here, what changes were made there to resolve that issue. But somehow this affected logins in a pretty significant way over that period of time. But looks like everything else wasn't really affected. So this is, the monthly view, there is a weekly view, there is a daily view, etc. So this is the way that the data is collected. The way the data is presented is in this, little table with green, yellow, or red boxes. And these boxes depend on these pre-configured thresholds. So each of these boxes is a test of a particular action. And you can see each test has a corresponding threshold. And when you configure a threshold, you basically set under what threshold is it considered green, under what threshold, between that and the next threshold, it's considered yellow, and then above a certain threshold is considered red. So let's take logging in as an example. Anything under 20 seconds is green, between 20 and 40 is yellow, and over 40 is red. And then obviously can be customized. So if we want to be, super aggressive on our thresholds for login. Let's say anything over 5 seconds is yellow, anything more than 15 seconds is red, and anything between 5 and 15 is going to be, sorry, under 5 is going to be green, between 5 and 15 is yellow, and 15 and above is red. And you can see that all of these logins that are 11 seconds fall between 5 and 15, which is why they've now been marked as yellow. So just a quick way at a glance to be able to tell how the system is performing. So that's one way to get to the data, is from this optimized performance monitoring view. The other way to get to it is from the user screen. So for instance, let's say we have user called Andy IT admin, or let's say Adam Citron on RDSH01, and we want to take a look at that user's performance. We can click on view performance right from here, and this will give us that familiar table showing us the data for all the different tests, just narrowed down or filtered down to this one particular user. And then if we wanted to see more, we can click more, and that will take us into that more detailed view that we saw previously. So the way performance monitoring works is, because it's visual synthetic, it actually is executing those tasks as if the user was executing them. Sometimes it works, sometimes it doesn't. Like for instance, sometimes you'll open Outlook and it will not open, or it will crash. So then the system is pretty resilient. It will retry again on the next hour. If monitoring is enabled, so let me just reset this back real quick. If monitoring is enabled, but the results are not coming in as the system would expect, right? So the system updates every hour and it's expecting certain results. If results are not coming in, even though this box is set to on, it will automatically restart the performance probe, right? Could be it ran an update, or could be the VM crashed, or whatever the case is. But if it's seeing that the performance probe is on, but it's not receiving data, it is going to proactively reboot this perf probe 01 VM, I believe once every 3 days or once every day or something like that. There's a certain algorithm by which it tries to self-recover from inability to receive data for one reason or another. Because it's visual synthetic, as the UI of different Office products and in internet browser changes, like for example, the new mail button has recently changed in the version of Office in Outlook. So we actually had to adjust the Outlook test so it knows how to visually recognize the new mail button, and it's able to, to actually run the test. So there is occasional maintenance to the various tests that run as the UI elements of the various programs change over time.